All right, last section, 7.5, properties of trapezoids and kites. Here's our last quadrilaterals that we'll be talking about. All right, and these are known as trapezoids, which is again is a quadrilateral, but this one has exactly one pair of parallel sides. Okay, and the parallel sides are called the bases. Right, so base and base. And the base angles of a trapezoid are two consecutive angles whose common side is the base. So the base angles are here and here. All right, and the base angles here, B and A, will be, since these two lines are parallel, B and A is like a transversal, so these two will equal 180, and these two here will be 180, therefore equaling 360 and making a quadrilateral. Okay, and the non-parallel sides of the trapezoid are called the legs of the trapezoid. And then we have one more special feature here. It's called an isosceles trapezoid. So if you recall, isosceles triangle, two sides of the triangle are congruent. If the legs of a trapezoid are congruent, then the trapezoid is isosceles. So if these two legs are congruent, then that implies an isosceles trapezoid, which is this figure right here. All right, so let's see what we got here. We're going to show that QRST is a trapezoid, and then decide whether it's isosceles or not. Okay, so to show it's a trapezoid, we need one pair of sides to be parallel. So in order for it to be parallel, your slopes would have to be the same. So I'm going to show that the slope of RS could be the same as the slope of OT here. RO is not the same slope as ST, so we can very easily see that. So let's find the slope of RS here. All right, so RS is, I'm going to do 3 minus 4. All right, difference of my y's, 3 minus 4, and 0 minus 2. And 3 minus 4 is negative 1, 0 minus 2 is negative 2, and I get a slope of 1/2. So this slope here is 1/2. Now let's find the slope here. So slope of OT, so we got 0 minus 2 over 0 minus 4, which is negative 2 over 4, 2 over negative 4, or 1/2. So same slope. Right, so indicates there's one pair, or exactly one pair of opposite sides are parallel. Therefore, trapezoid. Okay. So now, in order for it to be an isosceles trapezoid, then RO would have to be equal to ST. All right, RO would have to equal ST. So RO we can count because it's vertical, 1, 2, 3. So RO is equal to 3 units. Easy enough. And then ST, let's do ST here. ST, if I use the distance formula or the Pythagorean theorem here, it doesn't matter. I'll go with the Pythagorean theorem here. So this is 2 units and this is 2 units. So this is going to be 2 squared plus 2 squared. 4 plus 4 is 8, and I can see that the square root is not equal to 3, so this is not isosceles. Right, so ST does not equal RO, and again you could use the Pythagorean theorem or distance formula here, it doesn't matter, but both sides are not congruent, therefore not isosceles. Is it a trapezoid? Yes. Trapezoid because RS is parallel to OT, trapezoid. RO is not congruent to ST, not isosceles trapezoid. Okay, this one's not in your notes, just threw an extra example on here. All right, English, again, is this trapezoid and is it isosceles? AB and DC are the ones that look parallel. Let's see, I'm gonna do this one with a rise and run here. So I have a rise of 2 and a run of 1, 2, 3, 4, 5, 6, and a run of 6. So the slope of AB is equal to 2 over 6 or 1/3. Right, and I'm going to use this 2 over 6 again because I'm going to use that as part of my right triangle here to find the length of AB. So the distance of AB is equal to the square root of my rise and my run. So 2 squared plus 6 squared. And 36 plus 4 is 40. Right. Actually, let me scratch that. I don't need that distance there. Sorry about that. I'm going to find the distance of AD instead. Oh, sorry about that. Okay, so AB, and then I'm going to find the slope of DC here, and again, I'm going to use the same technique here. I'm going to find my rise and my run. So my rise is 1 and my run is 3. So the slope of DC here is a rise of 1 and a run of 3. So same slopes. Indicates exactly one pair of parallel lines. Therefore, trapezoid. Is it isosceles trapezoid? It's isosceles if, so it's going to be isosceles if AD is equal to BC. Right, and I'm going to use my right triangle here to create this. So AD, I'm going to make a right triangle here with A and D, and A, and then this is 1, 2, 3, 4, so it has a distance of 4, and 1, 2, 3, and a distance of 3. So AD is equal to the square root of 4 squared plus 3 squared, which is, I'll bring it down here, 16 plus 9, which is equal to 25, which is equal to 5. And then I'll do the same here with BC. And BC here has, it's just a vertical line, which is nice and easy to count. So 1, 2, 3, 4, 5. So BC is also 5 units. So AD is 5 units, BC is 5 units. So yes, they are both the same. Therefore, this is an isosceles trapezoid. So yes, isosceles. All right, a couple theorems your way. Isosceles trapezoid base angle theorem. If a trapezoid is isosceles, then each pair of the base angles is congruent. So if it tells you it's isosceles, so the trapezoid is isosceles, then A is going to be congruent to D, B is congruent to C. Right? The base angles are congruent. And here's a converse, right? So in the converse, I'm going to use some properties to prove it's isosceles. It says if the base angles are congruent, so AD or BC in this case, then it's going to be isosceles as well. So if a trapezoid has one pair of congruent base angles, then it's an isosceles trapezoid. So as long as one of the pairs of angles or base angles are congruent, then it's isosceles. And then here's one about the diagonals. If a trapezoid is isosceles, if and only if its diagonals are congruent. Okay, so in an isosceles trapezoid, the diagonals must be congruent as well. Alright, so even if you didn't know the base angles, what the base angles were, if you knew the diagonals were congruent, then this is isosceles, and therefore then the base angles are congruent, and so on. Alright, let's take a look at the next example. Okay, so the stone above the arc in the diagram is an isosceles trapezoid. Okay, so we know this is an isosceles trapezoid. So if this is an isosceles trapezoid, then the base angles are congruent. So angle K is going to equal to angle L, right? Those are the base angles. So angle L is equal to 85 degrees. So angle K is going to be equal to 85 degrees. And then we also know the other base angles, angle J is going to equal angle, so the measure of angle J is going to equal the measure of angle J and M. All right, and we know that, again, we said this is 85 degrees here. All right, and again, we know that KL is parallel to JM, and LM is in fact acting as a transversal. So if this is 85 degrees, then this is going to be, then angle M here is going to be supplementary, so it's going to be 180 minus 85. So 180 minus 80 is 100, minus 5 is 95 degrees. So angle M is equal to 95 degrees, and the measure of angle J is also going to be equal to 95 degrees. Alright, so coming back to the mid-segment here, and we talked about that, and now we're going to talk about the mid-segment of a trapezoid. Is a segment that connects the midpoints of the legs. Alright, and to further that one, so if the mid-segment of the trapezoid is parallel to each base, so MN, so AB is parallel to DC, the mid-segment will be parallel to all the, both of those as well. So AB is parallel to MN, and MN is parallel to DC. And also, MN, the mid-segment, is going to be half the sum of AB and DC. Right, so if AB, however long AB is, add the distance of AB, add the distance of DC to each other, take half of that, and you'll find the distance of MN here at the mid-segment. Okay, let's do an example, number 3 here. All right, in the diagram, segment MN is the mid-segment of the trapezoid. Find MN. So MN is just equal to half the sum of PQ plus SR. So let's add PQ and SR, which is 28 plus 12, which is 40, and then take half of 40, and we get 20. So MN is 20. And if you notice, 20 is 8 units away from 12, and 20 is 8 units away from 28, so that's smack in the middle. Alright, and then we have some information here about a kite, and I just want to go off on a separate piece here and just show you some other theorems about kites that are not in the notes, and we'll do that very quickly. Alright, so a quick little theorem about the kites here. Well, the kite is a quadrilateral, so we know that. So all 4 of these angles must equal 360, right? So we know that piece here. But we also know something else about angles D and F here, okay? So in a quadrilateral kite, if a quadrilateral is a kite, then the diagonals are perpendicular. So if you draw a diagonal from CA to BD, they're perpendicular. The 2 sides here are congruent, so BC is congruent to AB, and then these 2 sides here, CD, are congruent to AD, right? So that's what makes this a kite. And then one other piece here is if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent as well. So angle C and angle A, where the perpendiculars make here, those 2 angles are congruent. So when I'm looking at this piece here, it says one pair, right, exactly one pair of opposite sides are congruent. So if this is 115 and this is 73, then this angle D and this angle F must be the same thing. So this is x degrees and this is x degrees. So when I'm writing this as an equation, angle D and angle F, so it's going to say 2x, right? So it's 2 of those angles plus the 115 plus the 73 all must come together and equal 360 degrees for a quadrilateral. So 2x equals 280, 2x plus 288 equals 360, right? 115 and 73, and then subtract 288 from both sides here, and I get 2x equals 72, divide by 2, and I get x is equal to 36 degrees. So the measure of angle D, which is x in this case, is going to be equal to 36 degrees here. Alright, and then here's our last piece here. Quadrilateral, anything that has 4 sides. If those 4 sides are parallel to each other, automatically fits into a parallelogram. If at least one pair of opposite sides are parallel, then trapezoid. and then a kite here if the quadrilateral is a kite, if the diagonals are perpendicular, or the opposite angle is perpendicular, that becomes a kite. Then your parallelogram, is it a rectangle, is it a rhombus, or is it a square, depending on those properties. And then your trapezoid, can your trapezoid be an isosceles trapezoid? And again, if the base angles and the opposite sides are congruent, then it's a trapezoid, and the diagonals are congruent, trapezoid. Okay, so all the other properties here. But this is all the the most basic, anything 4 sides, quadrilateral, and then more specifically depending if the characteristics fit. So we'll finish off with this one, and I want to give this most specific name here for this quadrilateral here. Quadrilateral, there's no indication that any of these sides are parallel, but it does show me that the diagonals do bisect each other. And if the diagonals bisect each other, that implies that this is a parallelogram. Right, so if we go back to one of our theorems here, if the diagonals bisect each other, it is a parallelogram. We don't know that if the diagonals were congruent to one another, then we could go and say this is either a rectangle or square, which we don't have any indication there. If we had some indication that the diagonals were perpendicular to one another, we'd have, we could say that that's, could be a rhombus at the very least. We don't have that. We don't have any more information than the fact that these diagonals bisect each other. So at the very most, or the most specific name that we could give this thing is called a parallelogram. Right? Without any other information, we can't call this anything else.